So in this video, we're going to be looking at the sum of this series, and we were asked to evaluate from n equals 1 to infinity of 5 over 6 to the n. Now hopefully in your lecture or wherever you're obtaining your calculus 2 knowledge, you've learned about the harmonic series. And you know that it diverges. Maybe you didn't learn the proof, so I want to explain it here. But this solution is actually quite simple. It diverges because the harmonic series is divergent. Remember, the harmonic series is denoted most simply as 1 over n. In this case, we have a constant of 5 over 6. So this is 5 over 6, 1 to the n. So just a simple harmonic series. We know it's going to be divergent, so we don't really have to do much work here. You just say, oh, it's divergent, it's a harmonic series. But there seems to be no proof that is readily given to students sometimes, and I just want to explain that. You can find it online. They do a lot better job. I'm just going to quickly summarize it, maybe if you haven't seen it. So let's take our first series where we have 1 over n. So it's 1 over 1 plus 1/2 plus 1/3. Now take this series where we go, and I won't give the formula for it, but it's just 1 over 1 plus 1 over 2 plus 1 over 4 plus 1 over 4 plus 1 over 8 plus 1 over 8 plus 1 over 8 plus 1 over 8. You see how for every term we're growing by a factor of 2, but our denominator is growing by a factor of 2. So it kind of just keeps growing like that little pattern there. Would you agree? Oh, I dropped my marker. Would you agree that this... Oh, my marker's dead. Yoink. Would you agree that this series here is greater in value than this one here? Well, you'd say yes, right? Because we have the first couple terms are the same, but then we have 1/3 versus 1/4, and we know that for our third term, that 1 over 3 is bigger than 1 over 4. So this series is greater than this series here. Now what this means is that if we can show that this diverges, well then this also has to diverge because this is greater than the sum of these values. Well, there's a simple thing that we can do is we can combine terms here. So we have 1 plus 1/2 plus 1/2, because 1 over 4 plus 1 over 4 is 1/2. Combine all the 8s, that's 1/2. Combine all the 16s, that's 1/2. This is going to diverge to infinity. And because this series is greater than this one, well, in theory, it's greater than infinity. Therefore, it's also divergent, right? It's kind of like, you remember like squeeze theorem, right? If something does something, then the other thing has to do the same thing. Or not squeeze theorem, but basically divergence, convergence test. It's always going to be going up greater than it, so it will also diverge to infinity. That's why we say for this series here is divergent, and the sum of our values is infinity. We cannot determine a normal convergent value for it. Hope you guys enjoyed this video. If you did, please drop a like, comment, and subscribe, and I hope that you have a wonderful day.